In this video, I want to show you guys how to take the derivative of a function using the chain rule. And you want to use the chain rule to find the derivative when you have a function inside a larger outer function, and the inside is something other than just x. So say if we had the function x to the 7th, we would not use the chain rule to solve this problem, okay, because the inside is just x. In this case, we have a function right here, 7x plus 10, inside a larger outer function, which is to the 10th power, and the inside is something other than just x. So this is a prime example to use the chain rule, okay? So the first thing, so the way we use the chain rule is we take the derivative of the outside function, and it's just, we're just gonna say to the 10th power, that's the outside function, times the derivative of the inside function, and in this case the derivative of the inside function is 7x plus 10. So what we're going to do is we're going to start by taking the derivative of the outside function. So we're going to bring down the brackets, and to take the derivative of the outside function we're going to use the power rule, and the power rule states that we take the exponent and we bring it out to the front as a coefficient, and then we subtract 1 from the exponent, and that is what we do. So let's do that down here. So let's take 10 and bring it out to the front. So we're going to have 10. We're going to subtract 1 from the exponent, so that's going to leave us with 9. And then we're going to keep the inside function the same. So 7x plus 10 is going to remain unchanged, and we're just going to bring it down into here, 7x plus 10. Then we're going to multiply it by the derivative of the inside function, and as we found here, the derivative or the inside function is 7x plus 10. We can use the sum rule to find the derivative of the inside, and the way it works is the derivative of the sum is equal to the sum of the derivatives. So if that doesn't make sense, I'll show you right here. So the derivative of the sum is equal to the sum of the derivatives. So we're going to take the derivative of 7x plus the derivative of 10. Well, the derivative of any constant is just 0, so this is going to be 0 plus, and the derivative of 7x, we can use the constant multiple rule, which states that any constant multiplied by a variable to the first power is just a constant, but in actuality it's just the power rule, right? Because it's 7x to the first power, we bring the 1 to the front, so this is going to be 1 times 7. We subtract 1 from the exponent, which would leave us with 1 times 7x to the 0th power. X to the 0th power is equal to 1, so this is going to be equal to 1 times 7 times 1, which is just equal to 7. So from here on out, just remember that the derivative of any number, and we'll just use 7 in this case, times a variable to the very first power, the derivative of it is just equal to the constant. So in this case it's 7. This is going to save us some time. I don't want to have to go through this every single time, but the derivative of 7x plus 10 is now just equal to 7. So we're going to multiply it by the derivative of the inside function, which is 7. And this is actually the answer to the problem. However, we can simplify it further by multiplying 7 by the constant 10. So we're going to say this is 70 times 7x plus 10 to the 9th power. And that is the answer to this problem. So this is another good example of needing to take the chain rule to find the derivative. We have an inside function nested with inside a larger outer function, and the inside is something other than just x. It's 3x plus 1. So we're going to go about it by taking the derivative of the outside function. Using the chain rule, we'll bring down the brackets. We're going to take 7 and move it out to the front. And then we're going to subtract 1, which is going to be equal to 6, and that's going to be our new exponent. We're going to keep the inside function unchanged, and we're just going to bring it down into this function right here, so 3x plus 1. And then we're going to multiply it by the derivative of the inside function, and the derivative or the inside function is 3x plus 1. So the derivative here is just 3 because 3 times any variable to the power of 1 is just the derivative, just the constant, and the derivative of any constant is 0. So the derivative of 3x plus 1 is 3. So multiplied by 3. And then we can simplify this. We can say 7 times 3 is 21 times 3x plus 1 to the 6th power. And that is the answer to this problem. So for a third example, you should try this one yourself. You should try it yourself and pause the video and see if you can get it. Okay, so what we're going to do is we're going to take the derivative of the outside function. So we're going to bring down the parentheses. We're going to use the power rule to take the derivative of the outside function, and we're going to take the exponent and move it out to the front. So this is now going to be 100. We're going to subtract 1 from the exponent, and that is going to be our new exponent. So that's going to be 99. Then we're going to bring down the inside function unchanged. So 18x plus 1, 2, 3, 4. And then we need to multiply it by the derivative of the inside function. And the inside function is 18x plus 1, 2, 3, 4. The derivative of this is just 18, so times 18. And that's the answer. We can further simplify it, but it'd be 1800 times 18x plus 1, 2, 3, 4 to the 99th power. And that is the derivative of this problem. So for our next problem, we're going to take h of x is equal to x squared plus 5x minus 6 raised to the 9th power. Okay, so at first glance, to check to see if we should use the chain rule, we have an inside function surrounded by a larger outer function, and the inside is something other than just x. So this seems to be a very good candidate for the chain rule. So we're going to go about it the same way. We are going to take the derivative of the outside function by using the power rule. So we're going to take the exponent 9 and move it out to the front. So this is going to be 9. Then we're going to subtract 1 from the exponent, and our new exponent is going to be 8. Then we're going to bring down the inside function and keep it unchanged. So this is going to be x squared plus 5x minus 6. And then we need to multiply it by the derivative of the inside function. And the inside function is x squared plus 5x minus 6. Okay. So to take the derivative of x squared, we use the power rule and take the 2 out in front. So there's going to be 2x minus 1 minus the exponent. So this is going to be just 2x plus 5x, if you remember, is just 5, since it's 5 times a variable raised to the first power, and a constant, the derivative of a constant is just 0. So this is going to be the derivative of x squared plus 5x minus 6 is 2x plus 5. So we can multiply this by 2x plus 5. And that is the answer to this problem. So for our next one, we'll say f of x is equal to x to the 4th plus 3x squared plus 1, all raised to the 5th power. So this is an inside function surrounded by a larger outer function, and the inside is something other than just x. It's x to the 4th plus 3x squared plus 1. So we're going to go about it the same way. We're going to bring down the parentheses. We're going to use the power rule for the outside function and bring 5 out to the front. It's going to be 5. Then we're going to subtract 1 from the exponent, and our new exponent is going to be 4. Then we're going to bring down this inside function, which is going to be x to the 4th plus 3x squared plus 1. And then we need to multiply by the derivative of the inside function. And the inside function is x to the 4th plus 3x squared plus 1. So the derivative of x to the 4th is 4x cubed plus the derivative of 3x squared is 6x. And then the derivative of 1 is just 0, so we don't need it. So this is the derivative of the inside function. So if we rewrote all this, this would be 5 times x to the 4th plus 3x squared plus 1 all raised to the 4th power times 4x cubed plus 6x. And that is the answer to this problem. So now we're going to get into trig functions. But the good news is that it's the same set of steps. First, we're going to check to see if we should be able to differentiate using the chain rule. So the criteria is we have a smaller inside function surrounded by a larger outer function, and the larger outer function in this case is sine, and the inside function is something other than just x, which in this case is x squared minus 3x. So to take the derivative using the chain rule, we're going to first take the derivative of the outside function, which in this case the outside function is sine of, well, this, but we're not going to take it. So the derivative of sine is cosine. So we're going to say cosine, parentheses, times the derivative of the inside function. Okay, so we're going to bring down the inside function unchanged, just like the other times, x squared minus 3x, and then we're going to multiply by the derivative of the inside function, and the inside function is x squared minus 3x. The derivative of this is 2x minus 3, so we're just going to multiply by 2x minus 3, and that is actually the answer to this problem. Okay, so for the next one we're going to consider tangent of x cubed. So try this one yourself. Okay, so we have an inside function x cubed, that's something other than x, surrounded by a larger outer function, which is tangent. So this is perfect. So we're going to take the derivative of the outside function, which is tangent, and we're going to take the derivative of tangent, and tangent is the outside function. So the derivative of tangent is secant squared. We're then going to bring down the inside function, unchanged. Then we're going to multiply by the derivative of the inside function, and the derivative of x cubed is 3x squared. And that is the answer to this problem. So our next two problems are also going to be trig problems. We're going to take, for example, take the derivative of secant 4x. If we look, we have a smaller function other than just x inside a larger function. So this should be perfect for chain rule. So if we took the derivative of the outside function, which is secant, the derivative of secant is secant tangent. So if we wrote the derivative of the outside, secant tangent, and then we can't forget to bring down our inside function unchanged. So 4x, and then times the derivative of the inside function, and the inside function is just 4x. So the derivative of 4x is just 4. So times 4. And that is the answer to this problem. So for our next one, cosine of x cubed plus 7x squared plus 6. Our inside function is x cubed plus 7x squared plus 6. And our outside function is cosine. So we can take the we can differentiate cosine, which is negative sign. Then we bring down our inner function unchanged, x cubed plus 7x squared plus 6. And then multiplied by the derivative of the inside function, and the inside function is x cubed plus 7x squared plus 6. So this would be 3x squared plus 14x. So if we rewrote this and multiplied it out, so we would say negative sign times, or negative sign of x cubed plus 7x squared plus 6 times 3x squared plus 14x. And that is the answer to this problem. So consider this problem. The derivative of the natural logarithm of x raised to the 7th power. Well, we have an inside function, ln of x, that's something other than just x raised to a bigger function, the power of 7. So we can do this the same way. We can bring down the parentheses and take the derivative of the outside function. And the way we could do that is using the power rule. Since this is raised to the 7, we can move this out to the front. So this would be 7. And we could subtract 1 from the exponent, which would equal 6 now. So that would be our new exponent. Then we could bring down our inside function unchanged, the natural logarithm of x, times the derivative of the natural logarithm of x. And if you didn't already know, the derivative of the natural logarithm of x is just equal to 1 divided by x. So this is equal to, so we would multiply it by 1 divided by x. And this would be our answer, but we could further simplify this to 7 times the natural logarithm of x raised to the 6th power divided by x. And that is the answer to this problem. So for our next problem, we have take the derivative of 1 divided by x squared plus 8 all raised to the 3rd power. So at first you might not know how to do this, but we can actually rewrite 1 divided by x squared plus 8 raised to the 3rd power and bring it to the numerator so it looks a little bit more familiar. So if we wrote x squared plus 8 to the negative 3rd power, these two functions are now the exact same thing. All we did was switch the sign to a negative, and that brings the denominator up to the numerator. So from here, this is just a simple problem, right? We have an inside function that's something other than just x, all within inside a larger function, which is to the negative 3rd power. So if we go about this just like all the other problems we've done, we bring down per set of parentheses, and we bring the exponent using the power rule out to the front. So this will be negative 3. You subtract 1 from the numerator, or from the exponent, which would be negative 4, and we bring down the inside function and keep it unchanged, x squared plus 8. And then we multiply by the derivative of the inside function, which the inside function is x squared plus 8. The derivative of this is 2x, so we multiply by 2x. And this is technically the answer, but we can do a lot of simplification. It doesn't look too pretty when your exponent has a negative, so we can actually change the sign to a positive and bring this down to the bottom. But first we're going to multiply 2x and negative 3, and we're going to get negative 6. And then we bring down the x squared plus 8 to the bottom by switching the sign to a positive. So negative 6, can't forget the x, negative 6x divided by x squared plus 8 to the 4th power. Okay, so for our next problem, we have the derivative of the square root of x cubed minus 7. And this also looks like, where do you even start? But we can actually rewrite this as x cubed minus 7 raised to the 1/2 power, because raising any function to the 1/2 power is the same as, say, taking the square root of it. Okay, and this is just like the other one. We know how to do this. We have an inside function other than just x, and we have with inside a larger function, which is to the 1/2 power. So what we can do is we can use the power rule to take the derivative of the outside function, and by taking the exponent and moving it to the front. So if we bring down the parentheses, we will have 1/2, subtract 1 from the exponent, which would leave us with negative 1/2, and then we bring down the inside function unchanged. So x cubed minus 7 multiplied by the derivative of the inside, and the inside is x cubed minus 7. The derivative of this is just 3x squared, so multiplied by 3x squared. And then just like the other one, we can do some simplification. So this is to a negative exponent. We want to bring this down to the bottom by switching the signs to a positive. So what's going to happen is this is 3x squared on top. So this is going to be 3x squared divided by 2, because the 1/2. So if we multiply 1/2 by x cubed minus 7 raised to the 1/2 power, we'd just divide by 2. So 2 times x cubed minus 7 raised to the 1/2 power. And this right here is the answer to this problem.